Good morning, student. Today we start chapter number third, classification of element and periodicity in properties. In this chapter, first we discuss previous done topic, that is Daubernian trade, Newland law of octaves, Mendeleev periodic law, and modern periodic law. Let us discuss one by one. The first one is the Daubernian trade. Daubernier arranged the group of three elements in increasing order of their atomic weight, and notice the atomic mass of the center element was roughly the average of first and third element. For example, Daubernier taking lithium, sodium and potassium, that is a group of three elements called triads. Group of three element is called triads. Daubernier took lithium, sodium and potassium having atomic masses 7, 23, 39. He noticed the atomic mass of the center element, that is sodium, was roughly the average of first and third element, that is lithium and potassium. Now let us check. From this experiment, it is clear that the atomic mass of sodium is the average of the sum of lithium and potassium. The main limitation of Daubernier trade, it could identify only 4 number of triads. That's why it discarded. Now let us discuss Newland law of octaves. According to Newland law of octaves, Newland arranged elements, group of 8 elements in increasing order of their atomic masses. He noticed the properties of every 8 element is similar as that of first element. I repeat again, Newland arranged element in their atomic increasing order of their atomic masses. He noticed the property of first and 8 element is similar, just like musical notes. But the main limitation of Newland law of octaves is it could apply only up to atomic mass number 40. It could not say anything about noble gases. Now let us discuss Mendeleev's periodic law. According to Mendeleev's periodic law, the physical and the chemical properties of elements are the periodic function of their atomic mass number. That means if we arrange elements in their increasing order of atomic mass number, elements repeat their properties after regular interval. I repeat again, according to modern Mendeleev periodic law, the physical and the chemical properties of elements are the periodic function of their atomic mass number. That is, if we arrange elements in their increasing order of atomic mass number, elements repeat their property after regular interval. The main drawback of Mendeleev periodic table is that number first is it could not say or could not explain the position of hydrogen. It could not explain the position of isotopes. That are the two main drawback of modern Mendeleev periodic table, which will be rectified by modern periodic law or modern periodic table. Let us discuss modern periodic law. According to modern periodic law, the physical and the chemical properties of element are the periodic function of their atomic number. That is, if we arrange element in their increasing order of atomic number, element repeat their properties after regular interval. According to modern periodic table, there are 7 horizontal rows. In modern periodic table, there are 7 horizontal rows. 7 horizontal rows called periods, while the 18 vertical columns called groups. I repeat again, in modern periodic table there are 7 horizontal rows called period and 18 vertical columns called group. Element in a same group show similar physical and chemical properties due to similar electronic configuration. Now let us draw modern periodic table in a systematic manner. As we know, modern periodic table consists of 18 groups. Let us draw the number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and then 18. In group 1, we have group first element, we have hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. The learning technique of group 1 is ली ना की रब से friendship. Lithium, sodium, potassium, rubidium, cesium, francium. Group 2 element consists of beryllium, magnesium, calcium, strontium, barium, radium. और बगैर मैगी के सारी बारात रही. लर्निंग टेक्निक इज बगैर मैगी के सारी बारात रही. बेरिलियम, मैग्नीशियम, कैल्शियम, स्ट्रोंशियम, बेरियम, रेडियम. From group 3 to group 12 there are D block elements. Start from scandium. स्टार टीवी केबल में फीकू नीकू जी. Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. And the learning technique is star TV cable में फी कू नी कू जी. Then यू जरा ना बनो मानो तुम्हारे रूप रंग पर अजी के दिया. Yttrium, zirconium, niobium, molybdenum, technetium, ruthenium, rhodium, palladium, silver, cadmium. Now Hg, Au, Pt, and then Ishwar, Osho, Rajneesh, Winter Tak, Hoff, lanthanoid series start, and thereafter actinoid series start. Now come on group 13 element. It's a boron, aluminium, gallium, indium, thallium. Learning technique is बैंगन, आलू, गाजर in थैला. Now group 14 काशी गए संत पोरबंदर. और कार्बन, सिलिकॉन, जर्मेनियम, टिन, लेड. ग्रुप 15 न्यूज पेपर आज सब बिके. नाइट्रोजन, फास्फोरस, आर्सेनिक, एंटीमनी, बिस्मिथ. ग्रुप 16 एलिमेंट ओमू, सोमू, सप्पे, टेलीफोन. ऑक्सीजन, सल्फर, सेलेनियम, टेरिनियम, पोलोनियम. ग्रुप 17 एलिमेंट फिर कल बारिश आई एट नाइट. Chlorine, chlorine, bromine, iodine, and statine. And group 18 element consists of Hina, Nina, or Kanina, Xerox, Rangine. That is helium, neon, argon, krypton, xenon, radon. So these are the some elements that belongs to modern periodic table. Here the some space are left vacant. Now let us write down the atomic number of these elements. It's a 1, it's a 2, it's 3, 4, 5, 6, 7, 8, 9, 10. Thereafter 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, thereafter 55, 56, 57. Now after 14 after lanthanum 14 elements are there which belong to lanthanoid, which are written separately in the main body of periodic table. These 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71. Thereafter 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89. Thereafter 14 elements belong to actinoid, which are written separately in the main body of periodic table. 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 1, 2, 3. Thereafter 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118. Now the question arises how we write or the symbol of element having atomic number greater than 100. For this, let us study IUPAC nomenclature of element having atomic number greater than 100. For 0 we indicate by nil, 1 is by un, 2 is by bi, 3 is by tri, 4 is by quad, 5 is by pent, 6 is by hex, 7 is by hept, sept, 8 is by oct, and 9 is by m. Since it is 104, so it is written as for 1 un, for 0 nil, for quadium, quadium. It's a un nil pentium, un nil hexium, un nil septium, un nil octium, un nil ennium, un nilium, un annium. It's a un bium, un trium, un quadium, un pentium, un hexium, un septium, un octium. So the atomic number of an element having atomic number greater than 100 is written like this format also. For 1 we use un, for 0 we use nil, for 4 we use quad, and we are adding em. There are some drawbacks of modern periodic table. These are: number first, the position of hydrogen is still doubtful due to its electronic configuration. It can be placed along with group 1 element as well as group 17 element. Number 2, the lanthanoid and actinoid are placed below the main body of periodic table. That is the major drawback of modern periodic table. Thank you very much.